We can get one more, Sharon. Is that all right? Maybe just grab one more. I'll get it.
Yeah, he's got it.
He's got it?
He's
Okay.
got it.
All right.
He's on top of it.
Half of it.
It's definitely more cozy,
This
like
is
having
nice.
all of us here. Yeah. So do you want to start?
Welcome.
opening-
Welcome. Come on in. Make yourselves comfortable. We are absolutely delighted today to have a very diverse and engaged oral session on the topic of educational data protection and social aspects of brain imaging. I'm Daniel Margulies, and playing the role of Sophie Valk today will be none other than the inimitable Jeske Damoiseau. We're delighted to have her. Thank you for coming. And in the interest of keeping things moving, we have a very tight schedule. We're going to move straight onto our first speaker. A reminder that you can ask questions either from the podium after the talk. We'll have 10-minute talks followed by 2 minutes for questions. You can either come right up to the microphone there in the center of the room or post them online. And yeah, we are absolutely delighted to have our first speaker today, Michael Marxen on AR NeuroVison, explaining brain function in 3D. Thank you for joining. Take it away.
Thank you very much. Is this on? Can you hear me? Yeah? Okay. Thanks to the program committee for the opportunity to present our work. I have nothing to disclose. I do actually research also in functional connectomics. And you may know the issue that you might have to actually visualize your findings. In particular, in a way that you can maintain the anatomical references. So in connectomics, we have had all these pictures, and I always was unhappy with them, that they would not allow me to see the brain in 3D and what the connections actually look like. So I had a vision, maybe 3 years ago, of shrinking myself, like in some movies where the men become really small and you can actually travel into the body, into the human brain, and see things kind of above you in a large scale. So this kind of vision, maybe now we're one step closer to that. Initially, however, we developed a web page, which we call ConExplore, where we already made a little bit of progress. Basically, we have one slice viewer on the left side, and you can select the brain region in that slice. And on the right side, you see the connectivity of that brain region. So most viewers do not support that kind of functionality. So we currently just use this to visualize some findings from our publications. Now, about AR NeuroVison. This is was the next project in line, and it became a reality when I met actually Matthew McGinty, who's the chair for immersive media at our university, and he had basically the skills to do this project. And I'm very thankful to Ranim Zarour, who did a lot of programming in this project. And also 2 new students that are working with me, Angela Paul and Ariana May, who are much better with AI tools than I am nowadays. And the movies that I'm presenting here are actually largely made by them. So this is actually Ariana's movie, and I'll just play it for you. I don't have too much to do myself in this talk. So
what if you could step inside the human brain, dissect every region, trace every connection, visualize what textbooks can only describe, from macro to micro, structure meets function, learn by touching, rotating, diving deep into the brain's architecture. Whether you're a student, researcher, or educator, this is neuroanatomy redefined. This is more than learning. This is understanding from the inside out.
So thanks to Ariana for producing this really kind of cool marketing video for our software. Now, a few things about our hardware. We use these goggles from Meta. The Quest 3 at the moment that we are using, the Quest 4 just came out. They are for virtual reality, but we use it more for augmented reality, so you can see the space that you're moving in, and you see some other objects. We use the Unity game engine. We program in that, and some tools for 3D modeling, Blender, ITK Snap. And Ariana particularly used to make the movies ChatGTP and narakey.com, sort of some AI tools. And within one day, she could make that video. So I was very impressed. Our objectives were basically to create an augmented reality where we could visualize the brain, its regions, and in particular its connections from one region to the other. And the application, the original idea was sort of a public outreach idea to bring these things, our findings, what we discover in science, say to the public in the museum. There's a hygiene museum that is very famous in Dresden to talk about medical sciences, for example. And then I also teach some courses with respect to neuroanatomy and brain function. I'd like to use it in these courses. And that could be in an interactive way, that I can be with the students in the same space. But I actually discovered that it's in some way more fun for the students to be in their own space and explore things by themselves. So I think that's maybe something we will pursue more so for interactive learning for the students themselves. It's also for researchers that you can look at your data in this three-dimensional space, because I actually have a lot of difficulty to read things from a matrix that has so many columns you can't even like label them with anymore. So I think even for us as researchers, it's sometimes good to look at what do the connections look like, structural connections, functional connections, and our application is actually the field of addiction. So I'd like to just show you 2 videos now that give you an impression of what we can currently do within the toolbox. So please have fun just watching.
Moving objects. To move around objects, simply point at it with your controller and hold the trigger to grab or use your hands. Slicing the brain. Open the menu and select the slice tool. Then, move your controller through the brain to make a clean cut. You can choose the type of slicing and move it to see different cuts. Brain explosion. To separate the brain into major regions, activate the explode mode from the menu. While sliding the button, each part will gently move outward, giving you a clearer view of how the regions are organized. Annotations. While holding button A, simply point at any brain structure to reveal its name and function. You can also use the Brain Parts button in the menu to navigate through labels manually, or move the red cube across the brain to highlight specific regions. Connectivity. Visualize the brain's internal networks. Lines will light up, showing how different parts work together.
So this movie was made by Ariana, and she used this AI voice. And the next movie was actually made by Angela, and in this case, she's talking herself, sort of in a real recording.
Let's try out the brain explosion, which basically helps us to separate all the brain regions from each other. And you can see that I've put it at the maximum value, and you can see a more expanded version of the brain. Let's move the Khan Explorer website also. Yes. So the main purpose of doing this is so that we can view the various connectivities as well as get information about each aspect of the brain by using an annotation menu. So if you place the cursor and you press the A button, you basically are able to view the connections from that region to every other region that it is connected to. And this is represented by curved lines. And the lines at the moment do not represent anything significant. It's just to represent a connection. We're working on making the colors the same as that of the target region, as well as changing the thickness of the lines with respect to the strength of the connection. So also you're able to see the annotation menu.
Yeah, so currently the annotations, we take some information from Wikipedia simply, but we in the future like to provide more targeted content for specific educational purposes, and that could be accessed here. So there are still a bunch of limitations and a work in progress, which we need to do, I think, to make this really usable for educational purposes. So we're working on currently improving the coordinate yoking, that different parts of the application are at the same MNI coordinate. We like to also provide a 2D slice, a slide viewer, so that you can make a PowerPoint presentation and view it in the augmented reality, because not for everything you will need 3D objects. We also are working currently with Zina Mansour, who's done a lot of work on DTI tracts, to import DTI tracts for example, in the connectivity view. And we like to, in the background, provide directories where the person to use this can actually place data objects, different brain parcellations, different connectomes, and different PowerPoint presentations that you can then call upon in the application, so that you don't have to do any programming to use this. Region selection is an important part because it's often overwhelming, the content that you see if you visualize 268 regions, like you just saw in this parcellation from the Allen Brain Institute. And then the one thing we like to do is we like to be able to record in a better way than just taking a video these scenes, so that in the museum then you have material that you can present to others. And sometimes you might need a reset button because you can get a little bit messed up with when you rearrange things and you're standing in the middle of a huge brain and don't find the menus anymore. Then sometimes it's nice to be able to just reset things. Content-wise, we're working on improving structural connectome currently. We have already sort of some published papers that have functional connectivity, for example, connections that matter for alcohol use disorder. We like to make different atlases available. And then we like to write stories for this application on the brain and addiction, or make up different learning tasks for medical students. I'm in a psychiatry department, and so we teach medical students. And the utility and evaluation of this is a little bit, I'm not used to this kind of more qualitative research. I think it's the first time that we're thinking of doing focus groups to improve such a tool. And we want to study learning efficiency, so we might collaborate with our research group on medical didactics at the faculty. And then maybe, I don't know, maybe next year could be a little bit ambitious, but maybe next year or the year after I can bring more of an exhibit in this kind of framework. And you can visit me, but just before actually, the last but one video I have is, there's no audio to this, but when it comes to this idea of being inside the brain and making yourself really small, or making the brain really big, this is currently as big as it goes. And it's like, I did feel when I was doing this myself that I got one step closer to this original vision that I at some point had. So thank you very much for your attention, and then happy to answer your questions. This is the last slide.
Yeah, very nice. I think it's time to move away from 2D journal pages. I agree with you. Your use cases were all about education and personal experience. Did you think about maybe figuring out a way to include this in articles that we publish?
Currently, on my poster, for example, I just had the barcode to access some video material in this regard. So I think that could be one way. I actually explored this Scholar tool to embed certain objects into my poster, but the videos that I made, they did not play well in Scholar, unfortunately. So maybe there's a year or two more to go to make these tools really to work well. But yes, I think now you can already point smartphones at posters to access 3D objects and these kinds of things. And This tool, for example, would be nice to record certain things you want to tell people out there with your publication that you can only describe in 3D. So yeah, I think it can be used to that.
Yeah, but maybe it'd be nice to talk to the journals and find out how they could accommodate this kind of content.
Yeah, thanks. I might. It's not the first thing on my list, but I'll keep it in mind.
Yeah, thank you.
Okay, well, thank you very much again, Michael, for this wonderful talk.